Figure 518, LogicalOperators.java. In this command line application, we're going to demonstrate Java's conditional operators and Boolean logical operators. These are both used to perform logical operations that combine conditions to create more complex conditions. Now, this particular program simply outputs the truth tables for each of the conditional and Boolean logical operators to show you, based on the conditions to their left and to their right, whether the overall condition would be considered false or true. That's for all of the binary operators. And we'll also take a look at the logical negation operator here as well. Now, in Java, the concept of the AND operator is normally written with the double ampersand, which stands for the conditional AND operator. This is an interesting operator because it performs short circuit evaluation. And what that means is, if the operator can already see that its left-hand side is false, it won't even bother to evaluate the condition on the right side, because the only way an AND operation can be true is if both the left side and the right side are considered to be true. So given that, the conditional AND operator would only evaluate the left side condition in this case, and you'll notice here that we're representing our Boolean values using the keywords false, and down here the keyword true as well, which are Boolean values built into the Java language. You'll also notice in our printf statements that we're using a new format specifier. %b represents the Boolean format specifier, and it takes a Boolean value and automatically outputs it as the word false or the word true based on the value of the condition. So here we're saying if we were to combine two false conditions, what's the output going to be? And as you'll see in a moment, it will be false. And similarly, in this expression where we're comparing false and true, if the left-hand side is already false, whatever the condition is on the right-hand side would not get executed. So one of the things you have to be careful of when using this operator is to make sure that the operation on the right side does not have a side effect that needs to be applied, something that you must guarantee gets done. In fact, it's actually a pretty poor programming practice to define code where it's possible that a piece won't get executed based on the fact that this is a short circuit evaluation. You probably would find code out there that does that if you look around hard enough, but in general it's considered a better programming practice to write your code so that the order of evaluation of the operands around a given operator is not relevant to the actual code that you're writing. Turns out in Java that you're guaranteed that the order of evaluation of the operands around a given operator is left to right. So for this particular expression, we'll also get false, as we will on line 12 here. But in this case, because the left-hand side expression is already true, the operator is not sure yet if the overall expression is going to be true or false. So it will indeed evaluate the left side in this case. And same thing is true here on line 13 as well. When we execute a condition with trues on both sides of the conditional AND, it will definitely evaluate both expressions in this case to determine if the overall expression is true or false. So the first three lines in this part of the example will result in false values, and then only this version will result in a true value. And in fact, if I go ahead and run this right here inside of the NetBeans environment, we can take a look at the first chunk of our output here and show you that indeed we get 3 falses and a true as our results. So here is the conditional AND part of the output: false, 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 and true. So let's take a look at the conditional OR next. For the conditional OR, we're going to be using the double vertical bar operator, which is the same operator as in C, C++, and C# as well. And this too is a conditional operator that uses short circuit evaluation. This operator compares its two conditions and it returns true if either or both of them are true. So when it looks at the left-hand side condition and sees the value false, it has to evaluate the right-hand side condition to determine if that one is true, which would cause the overall expression to be true. In this case, both values are false, so the result of this one will be false. In this second case, we have false on the left side, so it still doesn't know if the overall expression is true or not. And because we have true on the right side, it is indeed true. In the third case, we have true on the left side, so here's where we get the short circuit evaluation. Now the whole expression is guaranteed to be true, because if either or both of the expressions is true, the whole thing is. So it does not evaluate the right-hand side. And then finally, the same is true for this expression as well. Because the left side is already true, it will not evaluate the right-hand side. And going back to our run of that example, you can see here for the logical that's the wrong one. You can see here for the logical OR, the conditional OR operator, that we get false for the first expression and true, true, and true for the remaining expressions. Okay, so let's continue now with the Boolean logical versions of the AND and the OR. They look similar in that they use the same symbol for the operator. This is a single ampersand and a single vertical pipe operator. These are also bitwise operators, just like they are in C and C++, but depending on their context in Java, they're either considered to be bitwise operators or Boolean logical operators. So if the left and right sides of this operator are integral values, integers, then it would be considered a bitwise operation. If they're Boolean values, it's considered a Boolean logical operation. And the only difference between the single ampersand and the double ampersand operators in a Boolean context is that the single ampersand is guaranteed to execute both its left side and right side operands. So it doesn't matter if it already knows the whole condition is going to be false, it's still going to evaluate the condition on the right side, and that's going to be true for each of these. So it will produce the same truth table as the double ampersand operator. So if I scroll down here, you can see that when I compare the values false and false, I get false, false and true gives me false, true and false gives me false, and the only case where I get true is where both conditions are true. Similarly here, when we look at the Boolean logical inclusive OR, the single pipe operator, the only difference between this and the conditional OR is that it's guaranteed to execute both of the conditions or evaluate both of the conditions on its left and right sides. So again, this is going to result in a true value if one or both of its operands are true. In the first case, both are false, so the overall value is false, and you can see that down here in the first part of our truth table. And in all the remaining cases, the result will be true, and the key thing is that it will not perform short circuit evaluation. So even though at this point in the condition true or false, we know the overall condition is true, it's still going to evaluate the right-hand side. One additional Boolean logical operator that we have is the so-called exclusive OR operator, which is the caret operator. And this one is going to return true only if one of its operands is true. If both are false, or if both are true, the overall value will be false, and this operator also is guaranteed to evaluate both of its operands. So these middle two lines are going to result in true values, and you can see that down here in the truth table for the Boolean logical exclusive OR. And then finally, we show you the output for the logical negation operator or logical not operator, which is simply going to reverse the value of a condition. So when I output not false, I get true, and when I output not true, I get false.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than live lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live Lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.